This problem shows us a graph that has like a U shape in the middle and a couple branches on the sides, and it's asking us three questions. First off, where's the limit defined? Where's the function continuous? And where's the function differentiable? Those are like increasing levels of niceness about a function or a graph. Let's talk about it. What do those terms mean? First off, what does it mean for a limit to be defined? Well, let me show you what it means to not be defined. So do you remember? Like if a graph kind of goes up here like this, solid dot, then down like that, then right there at that point, it's not the limit is not defined because it's got to be the same. It must be the same from the left and the right. Remember, that's the big deal. From the right and the left, the limit it has to be going to the same height for the limit to exist there. So we notice at one on the left side it's going up to infinity. On the right side of one, it's going down. So that's different. So one is a no-go, and four is a no-go. It's going up to the right and down on the left side of four. That's different. That's not the same. It must be the same for the limit to be defined there. It's not. So one and four, it's not defined. Well, that's how they wrote the interval. See how they're using parentheses? Remember that parentheses don't include the edges. So see how the one is not included, and also four right here is not included because four is not. Let me do a better job on that one because four is not in either one. Because if I write 0, 1 like that, it does not include one or zero, zero or one, what I should say. If you do bracket 0, 1, that includes 0 and 1. So brackets have a straight edge. I always think they're straight on the point, includes the 0. Parentheses are around. You're around 0. You're around 1. You could be 0.9999, but you're not right on 1. You do not include the 0 or the 1. So when they put a parenthesis on 1 or parenthesis on 1, they're not including the 1. Because you might say, isn't this just the same as saying like 0 to 7? No, it's not. Because 0 to 7 would include everything between 0 and 7. Wouldn't include 0 or 7, but include everything in between. We're not including the 1 and the 4 because the limit is not defined at 1 or 4. So it doesn't include the 1, doesn't include the 4 in either interval. If it was a bracket, that would include the 4, but we're specifically putting parentheses, not including the 4. Like that. Okay. And and also they said endpoints are not included. So that's why we have parentheses because you might wonder, well, 0, it's good. Well, they told us don't include the endpoints. Don't include 0, parentheses, don't include 7. Okay, next one. Continuous. Where's it continuous? Continuous means that you don't pick up your pen, right? You know that. So if you draw this graph from left, right, boom, right there, I got to pick up my pen and come down here, and then boom, right there, I got to pick up my pen. So again, it's at 1 and 4. It's not continuous, so it's the same answer as where it's not differentiable. Now, final function, I'm sorry, where the limit was not defined. And then final one, where is it different? What does differentiable mean? Differentiable means smooth. It's a higher level, probably the highest level of niceness. It's a preview of coming attractions for chapter 3. It's what we're about to get into, taking derivatives, talking about a function being differentiable. It's differentiable wherever it's smooth. So not only has it got to be, same left and right, limit defined, and continuous, not jumping, but also smooth, not meaning not jagged. You can't have a jagged point. So what would that look like? So a jag, like if you had a little graph here. Whoop, that was kind of a funny graph. Try to do that carefully there. Well, I did the same thing. Whatever, good enough. So you have a graph, it's going like this, and whoops, let me try again. So you have a graph, and then it suddenly, it's smooth, but then there's like a jagged point right there. That would be not differentiable, not smooth. Differentiable, it's a big word. Diff, differentiable. Anyway, it's not smooth there. Anyway, where's this graph smooth? Well, it's smooth everywhere again, except for 1 and 4, right? If it's got to be connected to be smooth. It's not even connected at 1 and 4. So it's the same answer for all three of these. At 1 and 4, it's not smooth, not connected, not the same from the left and the right. And so there we go.